Hello everyone, welcome to Odin School. Today in this class, we are going to learn about two of the most important components in Tableau, which is external connections and table calculations. Talking about external connections, whenever you have a data analytical tool like R or Python, if you want to integrate that particular tool with Tableau to create the same visualization with advanced analysis, we can also do it with the help of external connections like R, Python, Tab, MATLAB. All those technologies can be integrated along with Tableau and generate an output out of it. Talking about table calculations, there are two different calculations in Tableau. One is calculated field, another one is table calculations. Using table calculations, what we can do is without creating an additional column, we can do data manipulation at particular segments. The window functions that are present in your SQL database is what table calculations in Tableau. So we are going to see how to create table calculations. If I wanted to create it as a column, how can I do it? Or if I don't want to create a column, just manipulate the data, how can I do it? Both those things we are going to see in this class. Before getting into the content, let's understand why should someone learn Tableau. Tableau is one of the most powerful data visualization and analytical tool. It helps us visualize raw data, which is huge in structure. Generally, when we have more number of line items in the data, what happens is it becomes really tough and tedious for any human being to understand what is there inside the data as numbers and text. Because when it is more than 100 or more than 20 or 30 numbers also, it becomes really tough for us to remember everything. Whereas converting those raw data into a processed information and presenting it in visual representation helps anyone to understand the context of the data much better. We all know that a picture is worth more than 1,000 words. Very similarly, data visualization helps you to understand the business in the form of visual representation. Hence, knowing Tableau becomes very vital irrespective of your IT choices. Even if you are going to be an analyst, if you are going to be a developer, you are going to be a support engineer, it can be any role, but knowing a data visualization tool helps you to understand what is happening in the business in both personal as well as professional lives. With that said, let me quickly introduce about Odin School. Odin School is a technology upskilling platform. They help us continuously acquire new skills, and their motto is to stay skilled, and stay ahead. I am Gautam Kumar Jayachandran. I have 6+ years working as a senior data scientist. I have worked with several technologies in my current day-to-day life as well. I work in several technologies starting from Excel, SQL, Python, Tableau, machine learning, and analytics. That is pretty much an introduction. Let's see what is the agenda. The agenda, as we spoke in the first place, there are only two things. One is learning about external connection. Another one is table calculation. External connection. As I said, we can connect with any external analytical application and integrate it with Tableau to understand how it can be manipulated or used. Now let's see this in practical, because theoretically there is nothing here. We have to see how to connect with R. We will also see how to connect with Python. So first, let's get started with connecting with Python. I'll just close this. Yeah, this is enough. So first, what we need to do is, for connecting with Python, whatever interface you are using, what you need to do is you have to open your command prompt. So I'm using Anaconda interface. So what I'll do is I'll open Anaconda prompt to establish a connection between Tableau and Python. So I'm looking out for Anaconda prompt. Yes, we just need to open this. Once you open this, there are a couple of packages that we need to install before establishing the connection. We are going to use a server called Tableau Python, which is specified as TabPy. We will be using that to establish a connection. First, we need to see if it is installed or not. If it is not installed, we need to install it. Generally, by default, it is not installed, so we need to install it by our own. First, check your version. I'm going to check what is my current Python version, which is 3.7.4. Now, first thing what I have to do is I have to see if my pip is upgraded. So I'll say pip install -m pip upgrade pip. So I'm asking the machine to see if my pip, the installer that I have for installing Python relevant operations is up to date or not. If it is not up to date, what this particular command will do is it will upgrade my pip to the existing latest version of my installer. If it is already up to date, it will say requirement already satisfied. Basis your internet connection, this might vary from few seconds to a minute. And on top of that, well, I think I'll simply say pip upgrade, pip install pip. Say, let's say what happens in this case. It'll tell me what is the current version that it is using. It says requirement already satisfied. The latest version is what we are using, 20.2.3. So this is totally fine. So what we next need to do is we need to install tab.py. So I'll say pip install tab.py. That's pretty much what I have to do. I execute this. Once I execute this, since I have already installed tab.py, it will again say the same thing, requirement already satisfied. You have to install everything. One thing that you need to keep in mind while you are installing tab.py is your Tornado package. Yes, Tornado package has to be installed and it has to be 5.1.1. This package information has to be very specific, because other which ways tab.py server do not work. This is pretty much what we need to do in terms of installation. Before executing tab.py, what we need to do is we need to go to our Windows C and see if it is installed in our Python. In Python library site packages, if it is not installed in your site packages, you have to go to your user base, which is program data. In my case, I'll see Anaconda 3. In Anaconda 3, I'll choose library and then I'll choose site packages. In site packages, tab.py should be there. So yeah, tab.py is installed. Once tab.py is installed, you can confirm this, close this, go to your prompt. All you need to do is execute tab.py, which will establish a connection between your Tableau and Python. I have not opened Anaconda Navigator at all. I've just used a command prompt to achieve. Now it is connecting to a data source. Once it connects to a data source, I'll show you how to establish a connection inside Tableau. We have created we have installed the required packages. Now what we can do is we can establish the connection into Tableau through a small function. I'll go to help. In help, I'll choose. In help, what we have to choose is we have to choose settings and performance. In settings and performance, we'll have to choose manage analytics extension connection. Once you choose this, by default, if it will not be by default, it will be rserve. Unless or until you install tab.py, it will not be there. So you have to choose tab.py specifically here, and your server has to be local host if you are using a local your personal laptop. If you are using office laptop, you have to specify your IP address in this, and then the port should be 9004 only, as we saw it in the command prompt. All we need to do is test the connection first. Tableau will establish a connection and tell it is successful or not. It is testing the connection. Let's give it a minute. Okay, it is taking longer than usual. Let's give it another few seconds. Let me close this. I'll reopen my Tableau workbook. due to some issue, but that's fine. Once you establish the connection using your command prompt, all we need to do is open your Tableau workbook, go to help. In help, what you have to do is you'll have to specify manage external analytics connections. Once you choose this, you have to specify the port number which is generated out of the command prompt. By default for Python, it is 600. Sorry, it is 9004 only. So you have to just keep the port simply as it is. But your IP address has to be changed. Depends on your remote server or your local machine. Since it is getting connected, what I'll do is I'll try to connect with the data set. So after establishing a connection, I can also show you how to use Python inside Tableau. I'll choose help. I'll choose settings. I'll choose manage external analytics connection. What I'll do is I'll make it as a server. That way it will be faster. Okay, communicating on Tableau is unable to connect to the extension with extension. Accessibility pages. Okay, this is actually running in my system, but still it says throw some error. Let's fix this error. Perfect. So it says successfully connected to the analytics extension. There was some glitch. So once I redo it, it actually gets connected. Now Tableau is connected with Python in the backend. What we can do is we can write Python codes here to generate an output. Say for an example, I would like to perform principal component analysis, which can be done in Python. I'm going to do it in Tableau. How do I do it? The syntaxes does not vary pretty much, but one thing that we need to know is there are like few functions in Tableau that helps you to generate an output out of Python. So let me say PCA. This is what I'm going to do. Here there are only 4 functions that we can use for whenever we are connecting with an external application. We can use script boolean, which is basically if your Python piece of code or R piece of code is going to generate an output which is going to be boolean, you'll have to use this function. If the output that you are going to generate out of the Python operation is an integer, you have to use this script integer function. If the value that you are going to generate out of the Python operation is a floating decimal, then you have to choose real. Then you have string, as the name suggests. If the output you are going to generate out of Python is a string, you will be using script string. So these 4 types of functions only are available for all the different external connections. Now I'm going to import, I'm going to take the help of script real only, because the output that I'm going to generate by using Python is going to be in floating decimals. Let me show you how to execute this. Once you start script real, there are 3 blocks we need to remember whenever we are working with external connection. The first thing is importing packages. So I'll simply say import pandas as pd. Then I will ask the machine from sklearn. I would like to import decomposition also for performing PCA. And then sklearn dot in decomposition. I will import PCA directly. I don't want to write one more piece of code. Then I would like to import from sklearn dot pre-processing. I would like to import standard scaler also to standardize the data. Yes is capital here. Now this is the first block. The first block is importing the required packages. Once you import the required packages, then you need to supply the data information. Now I'm going to create a data frame, but the only small thing that you have to keep in mind is whenever you are working, whenever we wanted to create a data frame in Python, we directly give the column names and values to it. Here that is not how it works, because we have already loaded the data. Let's see how many measures are there in the data set. 1 2 3 4 5 only. Okay, 5 data is there. That's fine. I wanted to see what are the columns that are actually important and what are the columns that are not important. So I'm going to use all the columns. Before that, I would like to create a parameter also, because a parameter will decide how many principal components the user wants to see. So I'll first create a parameter. choose PCA, and the user can choose anything from 0 till 6. We can keep minimum as 0 and the maximum as 6, and the step size is 1, and it has to be an integer. Once this is created, I can edit my formula here. For creating data frame, the first thing is you have to give the column name. The column name is going to be discount. I'm going to use all the measures that we have here. For discount, where it is going to be present, it is going to be present in argument 1. You will not be specifying sum of discount which is there in the call data set. Rather, we will be specifying it as argument 1. I'll tell you how can this argument can be directed to discount in a little while. First, let's import all the columns. First discount, then I will say profit. For profit, it actually comes from argument 2. Then the third thing is profit ratio. Profit ratio comes from, will be argument 3 for me. Then I will have quantity, which will be argument 4 for me. This is the default syntax. Underscore argument is the default syntax for Tableau. To understand, there are Python relevant information. For R, it is dot. We will see R also, don't worry. Once quantity is done, let's use sales. I'll say argument 5. Once data frame is created, the first thing is to create the data frame. Then I will perform a standardization on this. So let me create a folder function called scale, which will have my function standard scaler. Once the standard scalar function is supplied, then I will transform this data into uh, a standardization. For this, what I'll do is I'll say scale dot fit underscore transform df. So now the data gets transformed. This is the second piece, and the third piece is performing the operation whatever that we wanted to do. In this case, I would like to perform principal components, and I wanted the user to decide how many principal components that they wanted to see. So what I'll do is I'll say n comp is equal to length of the columns that are there in the data set. Then what I'll do is I'll specify the function for PCA. PCA is equal to PCA. How many components should I have? That will be decided. All the components will be supplied in the first place, but the user can choose using the parameter. This is what n component PCA function is also done. Then we have to apply this function into the of sales. These 5 columns are supplied as an input. Once they supplied, what happens is the first argument will take the first measure that we have listed outside the Python function. The second argument will take the second measure that is there in the second function, and so on. It keeps going on and on. Once all these 5 arguments are given, I have also specified sixth argument. What is the sixth argument? The sixth argument is simply nothing but, okay, I did not specify it here, arg6. Column also, sorry, it should be column 0. Gives me the first column of argument 6. What is the argument 6? Argument 6 is the parameter, so the client or the stakeholders can choose what they wanted to see. I've given this information. That's pretty much what we have to do in terms of writing a Python information inside Tableau. Once this is written, what we can do is we can apply this and give OK. So here, if I would like to see this at a particular dimension, I will have to specify that by dragging and dropping it into detail. Say for an example, I would like to see how this information is distributed at a product level. It's loading a little while because I think there are multiple products. So let's give it a second. Perfect. So there are multiple products are there. That is a problem here. So that's not a problem. It's an advantage to us. So I'll drag PCA into columns now. Columns or rows wherever I wanted to keep it. I'll drag and drop it. And then I want the machine to perform this PCA on top of the product name. So what it will do is it will give us how many principal products are there. So out of all the products, what are the products that are actually performing fantastically well compared to all the other dimensions that we have. Now the what happens is Python is actually showing getting executed, and then it says error record value error. The number of components is 5, must be between 0 and minimum n samples with the standard vectorized solver should be full. So it says the sample should be 0 because we have not asked the machine to perform this operation on product name. So once I supply this, then it will work properly. See here, I don't want to see it in automatic. I would like to give it in circle. This is product name. Product name is, yeah. If I keep it here, the product names are not so very well distributed. I'll reduce the size. I think it is too big. And then what we can do is we can drag PCA into color. Again, it threw some error. Let's choose PCA. By default, it is 0. And then it keeps throwing me the same error. Looks like I have written something wrong in the code. Let me see quickly. Argument 6, the number of components should be all the columns I wanted to take. And I'm asking the machine to perform this. So okay, let's see what is the error again. Let me remove this. It says value error, n components should be 5, must be n components 5 must be between 0 and minimum samples and minimum. N samples and which is equal to go. The minimum value that I've written somewhere is wrong. Okay, is it because here I've specified something here? The current value is okay. The minimum value is 0, the maximum value is 6, which seems correct to me. Okay, n components 5 should be. Okay, let's do it this way around. Let's keep only 2 components. I would like to see only two things. I don't want to see anything in this. I would like to return everything. Yeah, it is because we have not dropped it now. After dropping this into row or column, what I can do is I can show a category or subcategory maybe into circle, and then keep this 1 and see what happens. Let me apply this logic across subcategory. Okay, it keeps throwing me some error, but the idea is pretty much the same only. We have to use the Python piece of code inside script boolean or script script integer or script real basis the type of output that we are planning to generate out of it. Let me finally try to decode this one more, last time. I've given 2 components. I can keep n comp also, and the 6th argument should return me only the 1 2 3 4 5 1 2 3 4 5 arguments I've given. It looks clean to me. Okay, let's apply this calculation directly here only. Compute using CT, and that's pretty much is what I have to do, I believe. Let's apply and see if this is throwing any error this time. Didn't throw any error, so we can directly drag and drop PCA into CT, I believe. I'll drag this into state. Here it says n components should be n components equal to 5 must be between 0 and minimum is actually 0. Okay, maybe because I'm keeping this minimum as 5 here, so I'll keep minimum. Okay. There are only 5 components that can be categorized. I think I'm keeping this wrongly. Index 5 is bound out of bound with for axis 1 with, okay, because in Python the indexing starts with 0, so we must be careful about that also. So the max, sorry, again it will throw an error. The minimum can be 4, the maximum can also be 4 only. So I don't want any step size for this, just keep 4. Again it throws some error, so some technical error that I'm having, but ideally it will work if I keep it at city, and then I can color this as I want it to have. It very clearly tells these, it has now distinguished into 2 different colors. If you wanted to add the city information, where is it, I can drag it and drop it in the label. That way it will tell Los Angeles and other cities like San Francisco, Columbus have a very poor PCA value, which means that they are of one separate group, and these Amarillo, Concord, and other San Antonio, Burlington, and Jacksonville has good PCA value. So we may can keep these two cities which are distinguished at principal component levels. We can choose as many numbers as we want. I think there are multiple cities that are there, so we can change the principal components in the parameter and then play with it. Here the idea is to just show you how to integrate with Python and how can you get started with it. So we were able to successfully write a PCO code and see that as an output. So this is one group, and then this is the another group, principal component 1 and a principal component 2. There are 2 components that we are seeing here. That's pretty much is what in Python. So let me close the command prompt in Python. Look at here, in the command prompt it actually generates all the value and calculations for which the logic for the logic that we have written. This is the value that the machine is retrieving from Python. Once this value is retrieved, the machine tries to generate a value out of it. Here I'm just going to close this. Once I close this, Python will now close the connection with Tableau will now close the connection with Python. Now connection is closed now, so we can just cancel this and go to R. Let's see how to connect with R. In Python, as we installed a couple of packages, the same way we will be installing packages in R also. But here, first we'll have to install.packages. We have to use install.packages, whereas I'll say R sub. So R should be capital. It's not R server, it is R sub. Let it get installed. Once it is installed, what we need to do is we'll have to specify, we have to call the library and activate it here before we connect it with Tableau. So let's wait for the machine to get this installed. It is asking you for a grand mirror. I'm just choosing India. Everything else can be automatically taken care by R. Now it is trying to connect the Indian mirror and then try to install this particular package ourselves. Once this is installed, it will be easy for us to connect with Tableau. I think it is getting installed. So let's give it another 10-20 seconds because it's not a big package. It's a small package. It will get installed swiftly. In the meanwhile, I'll close this. We can actually create another object for achieving the same type of output. Using R also we can do the same operation like building principal component analysis on top of it. We will see that in a while. We'll have to wait because the package has to be installed. I haven't installed ourselves so far, so I think since this is the first time, this is consuming a little time. Unable to open the index in India. Okay, let's choose a different mirror then. If the mirror that we have chosen for installing a package is not working, we have several other mirrors through which we can install. So where mirrors are basically different repositories from where it actually tries to get the package information, install it in your library. Once it is installed, we will call the library rserve and we will establish the connection with Tableau energy fee. Okay, in the meanwhile, let it install. In the meanwhile, I'll write the program which will fetch the data for us PCA from R. So the syntaxes will remain the same pretty much from Python, but let me just copy and edit it. That way it is easy. I'll edit what I have written in Python. Copy this, close this. The function of Python, function of Tableau remains the same. It will be script real only. I'm just going to paste this. However, the syntax of Python is different from R. So I'm going to change things. We don't have to do so many things in R because R has a pre-built pre-built function which has all the functionalities that these many syntaxes in Python can do. We have a function called printcomp. So what I'm going to do is I'll say printcomp. So this is the function that will have all the values that we need to have. So here in R, it is data.frame. The data frame object that we wanted to deal with is data.frame. We don't have to specify any information corresponding to the column header. Instead of dot r underscore r, we will give dot r1 r2. This is the syntax very similar to very specific to only R. You cannot use this for Python. You have to use this only for R. So 5 arguments are there, and then once we have these 5 arguments, what we need to do is if the correlation is true for this particular argument, we'll have to give it as true as well. So I'll simply say correlation is equal to, it is capital I believe. Once this is done, I think this is pretty much the syntax, and then we wanted to generate an output using a dollar symbol. So I would like to have the score generated by the machine. So I'll simply ask the machine to give me the score. The score has to be present in comma dot arg whatever the next argument is. The next argument is argument 6, and then I'll ask the machine to give it in first whatever value that comes in the first column of R. We would like to generate that as an output, and pretty much everything else is correct. Yeah, correlation is true, and I have asked the machine to generate the score for me. Once this is given, all I'm doing was I'm asking the machine to give me everything from the every row. I'm using a column comma here to generate every row, and then everything else looks good. Yeah, the argument 1 is sum of discount, argument 2 is profit, argument 3 is profit ratio, argument 4 is quantity, argument 5 is sales, and we have argument 6 which will be chosen by the user. And then I can apply this at a particular level. So what if I wanted to apply it at a country or region? Apply and give OK. Let's see what has happened in R. We have written the syntax. Once the connection is established, we will now be able to directly take this and dump it into the visualization. It says is not available. Okay, what we will do is we will write install rserve only. Install packages rserve. I'll ask for a cran library, cran path. I'll just specify a mirror which will work immediately, and then I think from there it will be able to easily pick it from and install it. Okay, let it load. Maybe once the connection comes into picture, I'll explain you how to connect. We have seen the difference between the syntaxes. If you are using Python, you have to use underscore. If you are using R, you are supposed to use dot annotator. Basically, that's pretty much the difference that you have to keep in mind. Everything else will work exactly the same way it will work. It has worked in Python for us. You will be able to drag and drop things, and then it will help you to pick values for you. I think okay, let's not use our console. I think it is too old for it to support. Let's use our studio, and then using our studio, I think we will be able to do this action very fastly. Let me pick RGY. Perfect. I think it got closed by itself. So what I'll do is I'll open R Studio. Using R Studio, since R is running in the backend, it will be easy for us to execute this syntaxes. Once RStudio opens, installing packages can be done through several ways in RStudio than in R console. Since R console consumes a lesser memory, I thought I'll do it there, but it is not responding to my requests of installing libraries. So I'm going to use RStudio to install it. You can use either of R console or RStudio. It doesn't really matter as long as we establish a connection through a particular port. Again, the port is 9001, I believe. Again, it will be captured by the Tableau by default once R service installed in your R machine. Again, it is taking a little time. In the meanwhile, I'll try to create views for our table calculations. I'll simply create some views that will help us understand business. I would like to see this year information across different ship modes and across the subcategories. That I think should be fine. Okay, or maybe I can keep this up. Yeah, in the columns. Perfect. So we have all four classes. In ship mode, I'll remove a couple of them or maybe one so that we can see everything in one sheet. It should be ship mode. I'm going to show sales. Perfect. Just a view for us to understand how table calculations can be taken care of. We are going to see several types of table calculations. But before that, looks like my RStudio is up and running. Let's take the help of RStudio to establish connection and play with the data. Once RStudio is open, we have to install the package ourselves as we try doing it in it is not completely running. Okay, let's give it a minute. Perfect. So here we can say install dot packages. So now we can expect the machine to execute this. It is running in the backend. Look at this. It means this is running in the backend. Let's wait for this to run completely. It couldn't figure it out. So what we can do is we can go to packages here, look for our so here it is downloading it. Required not install. Please do download and install the appropriate version of R tools before proceeding. So what it is doing here is it is downloading R tools, and it has downloaded RServe as well. Here, let me search for it. RServe is not there, so it has to be downloaded as the machine says. Perfect. I think it can be now installed. Our package install packages are downloaded packages. Looks like it has downloaded it, but has it installed it is something that we need to know. Yes, perfect. Here it is. So we will go to package, ask this machine to install this. It is running in the backend unless or until it this stop function goes. It means it is still running. Once this moves, yes, perfect. Looks like it is already in use. So what I'll do is first we will call library or serve. You have to just call this. Once you call this, you'll have to execute this. It says it is starting RServe for us. Once RServe is executed, RServe is running in the backend, we can go to Tableau directly, go to the help pane. In the help option, you can choose manage product keys, then wait for this to appear. Sorry, settings and performance, manage analytics extension connection. Instead of TapI, I'll choose RServe. As soon as I choose RServe, the local host and port remains the same. I'll try to test the connection to see if it is connected or not. Once it says it can establish the connection, we can just give OK. Another record, I think it keeps saying me the same thing. It is my local host only. Let me check this one more time. I think I have to change the port name, port number. Let me just check the port number. The default port for RServe for all the local computers is given in the screenshot. It is 6311. Yes, I'll choose 6311 and test the connection. Now, in this case, I'm sure it should say successfully connected. See here, it says successfully connected to the analytics extension. Just that the port has to be 6311 for a local computer. Just give OK. Now, your R Studio using R function also, R programming language as well, we can execute PCA. Let me show you that as well. It is running in the backend. It is performing this calculation that we have written in RPCAR. So I'll go to a new sheet and show you how PCAR is throwing us the output for the PCA that we try doing. Again, it has to be on a particular dimension. I will say ask this machine to choose country or region. Mm, Let me do this. Right click, edit. While editing, you can choose where it has to be passed on. I would like to keep it on sales, I would say. Don't have a maybe region. Okay, and then drag and drop it. Drag region into view. Now it will not throw any error. It should ideally show us the values. Communicating with the online error in printcom default. Data frame printcom can only be used with more units than variables. Uh, I think there are less information in the data set, so we have to choose a member that has more than uh, 4 are, I think we have used 5 units, so we'll have to choose a variable or dimension which has more than this. Manufacturer for sure has more members in it. Now this error should suppress by itself. Drag it somewhere and then drag manufacturer into detail. Now it shouldn't throw an error, it should perform the calculations for us and show the values. We can drag PCA that we have written here, change the data type into circle. Again, what I can do is I can keep the same thing in column also. That way it becomes both X and Y axis, and then it can be shown as a scatter plot. Okay, the data is very linearly distributed here. So what I can do is I can drag PCA R into color. So what happens is it again shows you what are the variables that has higher variance and what are the variables that has lesser variance. Looks like a lot of variables that we have supplied here below here are having very lesser variance. Various these variables, these members that are having in the data, are having higher variance. Canon, GBC, Canon again, Fellows, Ativa, Akko, these whatever manufacturers that are above this blue, present in blue, are having good variance compared to all the other members that are present in the manufacturer. Looks like Cisco is an outlier, very evidently. This also looks like an outlier, QB5 and QB5 again. These are other manufacturers, Ibico, QB5, and these are members in the manufacturer that show very less variance. These are members in the manufacturer that show really high variance. This is exactly what we wanted, so that can be done using both R and Python. I'll close the connection, other which ways it will be slower. Perfect. So that brings us to the external connections idea. The next thing is table calculations. Table calculations, as we speak, is simply nothing but whenever we wanted to work on a certain manipulation, data manipulation, there are two ways. The first way is to create a new column like we did for PCA and PCAR, and we can create a new column by writing a calculated field. Choose a drop down. I can write create calculated field. I'll say target as sales plus sales into some value. So what happens is this creates a new column altogether. It creates a new column and it can be used wherever it is required. But for the time being, only for the view purpose, the user might wanted to see what is the running total in the accessories subcategories across first class, across all the 4 years. What is the running total for all the subcategories, vice versa. So in those cases, we don't have to write separate columns as create separate columns and try to make the machine slow. Rather, what we can do is we can do window related operations directly through table calculations. By selecting the drop down here, the first option that I get is add table calculation, or I get quick table calculation. If you see quick table calculation, we have running total. What is the difference between each and everything? What is the percent difference? Percent of total, rank, percentile, moving average, compound growth rate, YOY growth as well. The same thing will be here also, but here we can suppress the data at more layers. Let's first see this running total. What happens when you give running total? What happens is it takes the value of accessories and adds it with 2017's value. Then both of them will be added to 2018. Then all three of them will be added to 2019, which is 22,227. Looks like it is added across the table. We don't want it to add across the table. Only under first class I wanted to know what is the running total. So what we have to do is I'll say compute using. In this case, see here, the computation is happening across the table, but we don't want this to happen across the table. I want this to happen only across the pane. So if I choose across the pane, first class will be calculated separately, second class will be calculated separately, and standard class will also be calculated separately. So I'll choose pane here. See here, as soon as I choose pane, within the table it gets calculated within this pane. 4000 plus whatever value that we had, then whatever value that we had in the previous two cases, along with all, we have for 22,000. For second class, it starts from the original value and then it adds only till this, then it adds till this. So what happens with pane is, let me use a big pen to explain this. There are different ways through in table calculations with which we can actually compute the data or the values that we wanted to calculate. Let me show you them. Choose edit calculations. If I choose edit table calculations, by default it gives me running total, which we chose in the quick table calculations. Whatever that we saw in quick table calculation will be present in the edit in this pop-up as well. So in this pop-up, as we have chosen running total, okay, as we have chosen running total, there are several ways in which the computation can happen. First thing is computation table across. What do I mean by table across? See here. Yeah. So what happens is, when I say table across, machine calculates all the values in this way. So it'll add the first value with the second value, the first two values with the third value, the first three values with the fourth value, four values with the fifth value, and so on. It keeps doing the operation at this level from left to right. See what happens when I do the operation by table down. So what happens is, the values that are here gets added with the previous one. Now it is top to bottom. This is what table down does. The first value gets appended with the second value gets appended with third value, and so on. Keeps happening at every level. What if I would do table across then down? The third option here is table across then down. So here what happens is, it performs both the operations. But how does it perform both the operation is something we must know. First, what it will do is, it will add all the values in the first row, and the total of the first row will be given to add the total of the next row. So it will actually perform a zigzag. First, it will add everything in this first row, and the output of this first row will be given in here to the second row, and then it keeps going doing the same operation here. Then again same thing here. It performs a zigzag but at a row level. Again does the same thing, again does the same thing. So this is what, from left to right and then bottom, and then it goes to left to right. This is how across then down works. Down then across, the next option is down then across. In down then across, what happens is, it will first calculate all the values that are here from top to bottom. The last value will be taken into consideration for adding the next value here. Then again it does the same thing from bottom to top, top to bottom, bottom to top. Keeps happening from each and every line item. So finally you will be seeing the overall total that we have generated in these three categories at in 4 different years. 21 lakhs 68,838 dollars is what we were able to achieve as sales by selling products across these three classes of ship modes. So we can understand the operation at a table level if you want, but the table level here doesn't help us in understanding the business properly. So we will go with pane across. What happens with pane across is that, only within this pane, let me use, only within this particular zone the calculation happens. This is my second one, this will be my third one. Within the pane the operation works, the logic will remain the same, the rest of the logics will remain the same. What happens when I choose pane across? It will calculate the numbers only from left to right and then keep it as it is. and then again it starts fresh from left to right, and then keeps doing the same thing only within the pane. What happens when I choose down in pane? So if I can say in pane, perform pane across then down. So what happens is the machine calculates the value here and then takes the last value to the first in the second row and calculates it as zigzag just inside the pane. Rather than calculating the entire table, it will do it inside the pane only. This is how we can take the help of running totals. The same happens with the pane, and the cell option here doesn't make any difference whatsoever. So there's no point of using cell because the values will remain the same as it is. This is the original data. Now there is a concept called specific dimension. How do you want this calculation to happen? You want this calculation to happen at a ship mode level, or a subcategory level, or at a year level. There are three information in this. So what happens when I give ship mode level? See here. When I choose ship mode, what happens is the calculation, the running total that we are having here happens only at a ship mode level. First class, second class, and third class. It doesn't change anything whatsoever. Then let me deselect this. Yeah. Subcategory, if I choose a subcategory, it will calculate the values down rather than up. It will left to right where we have this one where we have ship modes. It will perform up to bottom. And if I have year of order date, what happens is it will calculate the values at year level. In what year, how much of products have been sold and everything. Here I have not selected everything. If I choose year, so it will add values only from left to right because the year is also presented left to right. Ship mode and year as present as left to right, whereas category is present from top to bottom. That is how we can calculate this. Now let's see everything by calculation assistance. If I choose calculation assistance, it will tell how table across will perform. It will perform one row at a time and then goes to the second row. What if I do uh, let me choose. What if I choose down? It will take from top to bottom. What if I choose across then down? It will show the entire table. Same happens with down then across. But for pane, it will tell you within the pane it will work this operation. Across then down, it will show the entire pane. Down then across also same thing. Cell also will show you the entire thing, one cell at a time basically. So every cell, there is no calculation that will happen inside the cell, so it will be left as it is. So these are the different ways that we can compute the data. So I'll keep pane across then down as of now, or maybe pane across. This is the calculation level I wanted to do. Okay, but there are several types of calculation that can be done. So I'll choose editable calculations now. The first thing that we are seeing is running total, which will add the current value with the next value, current, and the last two values with the third value, and last three values with the fourth value. And then if I keep my mouse, it will tell me what is the order position of the running total. It is the fourth position, which means that it is an accumulation of the initial three values that are there in the particular line item. We can understand this as how many members are included to achieve this cumulative sum. Now the same table calculation can be used to perform different sets of statistical calculations. Say for an example, what I wanted to know the difference from. So the difference from is basically very simple. Let me close this. So what machine does is it will compare the first value. Yeah, it will compare the first value and the second value and tells what is the difference between 2017 and 2016. It is $2,831. Looks like 2017 has generated good revenue, good profit compared to 2016. There is an increase in profit. Whereas in 2018 it is minus $2,700, which means in 2017 we might have earned $7,500, whereas in 2018 we might have earned only $5,200 or $5,100. So there's a loss here. It compares my previous value with the current value. So previous value minus current value is this. Again, previous value minus current value is this. So 2018 will perform 2017 minus 2018, which will give us a value. Same happens with 2019 as well. Now this calculation can also be marked at a particular dimension, which where have as the machine to calculate this at uh, previous value and current value. Then let me edit this. Next thing is percentage difference from what is the percentage growth compared to my previous year. 61 percentage growth from my previous year, from 2016 to 2017. Whereas in 2018 we have a loss of 36 percentage. In 2019 we have a gain of 9 percentage. So looks like the business is very inconsistent in in the subcategory accessories for the ship mode first class. If I go to second class, in second class also, in second class I have performed really well in 2017. In 2018 it has again dipped down, whereas in 2019 I have picked up my sales. So looks like this is fine. In standard class also, in standard class there is no loss. The business has been continuously growing from 2016, 2017, 2018 and 2019. The business has been steadily growing. This is the difference in terms of percentage. Percent from, so what we can do is we can say what is the percentage of the current value from the previous value. So I might have 7500 in 2017. In 2016 it might have been 5100. What is the percentage increase from the previous value? So it might be the 7500 might be 161 percentage to 5100 or 5200 or 4800. So it tells you what is the percentage from the previous record. Then we have percent of total. It will tell you the percentage of total, how much each and every year has contributed to the overall sales. In the subcategories accessories, looks like 2017 has contributed pretty much more compared to all the other years in the first class deliveries. Whereas in other products, in other subcategories, we can see it for other subcategories also. Um, Looks like 2019 has performed really well for appliances. The same for art as well. And yeah, that's pretty much is what we have to see. So this gives you the percentage of total across the pane. If I wanted to see it across the table also, I can see, but here I'm just seeing it across the pane. A rank basis the value that is present inside the data, it actually ranks. There are like four different types of rank that can be performed over Tableau. The first thing is simply rank competition, where if there is a match or a tie, if say for an example two students have scored the same mark, what happens with competition is rank competition is that they will be given the minimum rank. If both the persons have scored 200 and 199 198 out of 200, they will be belonging to second rank. Even though there are two students, the rank will be 1 2 3. Here it will give you the second rank for both the people and it will skip the third rank. That is what rank competition does. Various rank modified competition gives the maximum value. Here it is simply competition. There is one more rank function called rank modified competition, where if there is a tie, it will give the maximum rank that can be possible within that bracket. Since two students are scoring same ranks, so second and third rank, instead of giving second rank, they will be given third rank both, and the second rank will be skipped. Then we have dense competition, dense rank. Whereas in dense rank, what happens is both the students will be given the minimal rank and no values will be skipped. So that if there are two students scoring second rank, then third rank will not be skipped. The third rank will be given to the fourth student. Talking about unique, it will not give distinct it will not give duplicate ranks irrespective of your score. Even if both the students are given scored 198, one student will get second rank. For the same mark, another student will get third rank. It will not create any tie in the data set. These are the four different types of rank that we can actually take help from table calculations. If you see competition, we can clearly see in accessories 2017 has been the best performing year. In appliances, in first class delivery, 2019 has performed well. The same is for art subcategory as well. In 2018, binders have performed fantastically well. Those things. This is rank. Then the next thing is percentile. It will tell you what percentile that particular number is falling within the distribution. So that top percentage, top 1% is basically of aggregation using summarized values. And then I can choose add the previous two values, then give me the next value 0. And that's it. So if you, what happens is the first two values gets added and you will be given the value here. Then the previous two values will be added and then you'll be given a value here. Then the previous 2018 and 2017 value will be added, not 2016. Only 2018 and 17 will be added and a value will be generated for us. So what happens is it will calculate the previous two from the existing value. In this case, in 2016, there are no previous information, so it will keep the values as it is. Whereas in 2017 also, you don't have two instances of previous occurrences, so it will, however, add only the first one. Whereas in 2018, it has the liberty to add two elements which is previous to this and give you the total. In 2019 also, it has the liberty to add the previous two totals. We can choose this previous two into anything. I can say previous one, previous two, previous three, anything as my wish, and then perform this calculation. That is what we can achieve using a table calculation. If we wanted to do the manipulation without creating a table, without creating a column, so I'll keep rank. So what we can do is we can see how to create rank or any other table calculations as a column. A table calculation can be done directly on the data set. However, using a calculated field, I can create it as a new column in the data set as well. So rank on sales, so I'll say rank. So it asks me what is the type of rank that I wanted to keep. I'll keep rank dense. And then what is the expression that I wanted to supply to perform this rank calculation. I would say sales. The rank has to be in ascending order only. So I'll say ASC. It should be sum of sales. Now the calculation will be valid. We can specify where this calculation has to happen. This calculation should be computed across cities. Just give OK, apply this, give OK, drag this rank, and drag city information also. We don't want any bar charts. I would like to keep it as text. I would like to keep it discrete. So it will give the rank according to the city. So let me sort this. This is in descending order, in ascending order. So Berlin gets the first rank, Ilria gets the second rank, Jupiter gets the third rank, Panascola gets the fourth rank. Let's see the sales value. Okay, I have given ascending. Let me simply change the rank into descending. The value, you can create a new column using the table calculations, but we can also write it to generate these values. So that's pretty much is all about table calculations and external connections. Perfect. That brings us to the end of this session. Now let me quickly recap what we have learned in this session. We have learned about external connections, where we learned how to connect with two different data sources, application sources. One is Python, another one is R. The one thing that we need to keep in mind while we are connecting with external connections is that the syntaxes for creating the table differs a little. The tables, since they are connected in Tableau, what we will do is we'll try to supply them as arguments. For Python, it is underscore argument and then it will follow a serial number. So with Tableau, using this external connection management. You just need to install appropriate packages in your local machine. For Python integration, you need to install tappy. Whereas for installing or integrating R with Tableau, you need to install rserve package. Then talking about table calculations, using table calculations, we can achieve data manipulation without creating a new column on top of it. There are several types of calculations that can be done in table calculations, starting from difference from percentage, difference from percentage total, running total, moving calculations, rank, percentiles, all those things can be calculated using table calculations. We can also create a column if we wanted to play with table calculations as well. That brings us to the end of the session. Thank you so much for joining this class. We'll catch up in the next class.